Good evening, my dear student. Today there was a technical difficulty, and that technical difficulty was my height. The camera was not being set according to my height, and that is why I had to wait. Sorry to keep you waiting. So let's begin over with the today's session. And today we are starting with a very important chapter and a very important session which has been deleted from NCERT incidentally. The chapter which we talk about is states of matter. Now, when we talk about this chapter which we call as states of matter, this is a chapter which is a compulsion if we want to do thermodynamics, if we want to do equilibrium, because in this particular chapter's topic are going to be used right there. But let's begin over with it. A bit about myself. My name is Anoop Vashishtha. I am an MSc in Chemistry from University of Delhi. 26 years of teaching experience. Lakhs of students have been taught by me, and I have seen the students getting all kind of good marks. Clear? I am perfectly fine. I believe all the students who are watching at this moment, they have already liked the session. And like, subscribe, share and comment. Isn't it? Hello, beta. So everybody has liked the session? Okay. So to get along further, let's get along with the chapter called the gaseous state. Now, when we talk about the gaseous state, it's a state of matter which is in which the particles are absolutely free to move around. The particles can move freely. They show all kind of motion, that is rotational, vibrational, translational motion, and the particles keep on moving until unless they collide with a physical obstruction. Till that time, the particles move absolutely in the straight line. Okay, perfect. So that is what we have as the gaseous state. Now today we are going to talk about the gas laws. We need to understand one very important thing. Chemistry works with something called observation. Chemistry works with observation. Just a minute. It started. Okay, now it is playing. So, we are going to talk about the states of matter, and I had talked about what are the gas laws. So here we have the session, that's my qualification. I'm an MSc in chemistry from University of Delhi, and we talked about something called the gaseous state. The gaseous state is the most free state of matter in which the particles are moving absolutely free of each other. They are able to move thoroughly and finely. Now let's get along with the general properties of the gaseous state. Okay. Gaseous state, the substance does not have any fixed shape or volume. Now when we talk about not having any fixed shape or volume, the substance occupies the volume of container. So the substance occupies the volume of the container. So it does not have any fixed shape or the volume of its own. It takes up the volume and the shape of the container. Now it has a much lower density than solids and liquid, and it is absolutely clear. The simple reason is, in the case of solids and liquids, the distance between the particles is extremely low. The solids and liquid do not have that much empty space as the gases. Further, the attractive forces, in fact, when we talk about any substance as a gas, the particles are moving absolutely freely. That is, they are not interacting with each other because they do not have the attractive forces sufficient to hold together the particles. And the thermal motion are able to overcome completely. Tirthraj Mukherjee, gases, they take up the shape of the container. Clear? Now, so here, this is having the weakest forces of attraction because of the distance. Now it exerts pressure equally in all directions. When we talk about the small containers, we can even say that the gases are not affected by gravity. The particles are moving absolute independent of gravity. The thermal motions, the movement of the particles are able to completely overcome the gravitational forces, and that is why the gases exert equal pressure in all the direction. They have infinite expansibility and high compressibility. The expansibility is simply because the particles are moving independent of each other, and compressibility is due to the empty spaces between the particles. Many a times we say this is absolutely empty क्योंकि इसमें हवा भरी हुई है. But air itself is not empty. The particles between in between the particles there is emptiness, not air. Now it forms homogeneous mixture. The gases always mix up to form homogeneous mixtures. They always dissolve in each other. Is this clear? So that is what we have something about the gases. Now the relationship between the measurable properties, the properties which we have done in the last class, in the yesterday's class, we talked about pressure, volume, temperature and mass. In gases also, we are going to talk about the relation between these very quantities: pressure, volume, temperature and mass. Now these the equations which give us the relation between these particular quantities, pressure, volume, temperature and mass, are termed as equation of states. So we are going to talk about the equation of states, and these gas laws actually represent the equation of state for these particular substances. So they are interdependent properties. They describe the state of the gas. So this is given as the equation of state. Now we have the various gas laws. We have Boyles Law, we have Charles Law, we have Gay-Lussac's Law, we have Avogadro's Law, and the combination of these gas laws gives us the combined gas law and the ideal gas laws. So we are going to talk about these very gas laws. Piyush says, please define infinite. But I am not a mathematician to define infinite. Only a few people are capable of defining infinite, and that is maybe Ramanujan. You can't expect me to be defining infinite. For me, the infinite is that once the particle of the gas starts moving, it will keep on moving till the time it gets a physical obstruction. So that's what is infinity for me. Is it clear, Piyush? Okay. Well, sometimes it becomes quite funny when the students try to oversmart me. Okay, let's get along with the Boyles Law. The very first law, the Boyles Law. When you talk about the Boyles Law gives us the relation between pressure and volume. What happened was that Boyles took a syringe and he placed a piston in it. This experiment you can even do it at your home if you are able to get a glass syringe. The plastic rubber syringe won't work because that has quite a resistance. But we are going to talk about the glass syringe. If we talk about the glass syringe, it has a very smooth movement. What you can do is you can simply start placing coins on top of it, and you will find as you keep on placing the coins, the piston will move with the same amount every time the coin is placed. So that what we mean, as the pressure increases on the piston, the volume will decrease, but the condition is the temperature and mass remain constant. So till the time temperature and mass remain the constant, the volume will keep on decreasing as the pressure increases. Now, Mr. Boyles, he created a graph, that is the pressure and volume graph. When he created a graph, the graph was not a straight line. In fact, what he got was, here he kept it as volume, and here we talk about pressure. As the pressure increased, the volume kept on decreasing. So as the pressure increased, the volume decreased. Here, pressure, mass and temperature have to be kept constant. If it is not kept constant, then here this is going to vary. The volume is going to vary because of the mass being changed or temperature being changed. We won't be able to find whether it is because of the pressure or because of any other factor. So that is why this has to be kept constant. Any kind of doubts here? Is it clear? Like. I believe there are certain students who have not liked the session as yet. So that is how it changes. But then what Boyles did was, he took another graph. And when he took another graph, he again made the graph of volume with inverse of pressure. When he made the graph of volume with inverse of pressure, then in that case he found that it turned out to be a straight line which seems to be passing through the origin, appears to be passing through the origin. Here it would mean, when we have 1 by P is equal to 0, it would mean pressure is infinity. Infinity means it is huge, so that it actually becomes 0. The volume also would become 0 at infinite pressure, but this is not possible, so it needs to be intrapolated. You may even term as extrapolate. Extrapolate is the word which is used most of the times, but intrapolate is towards the origin, extrapolate is away from the origin. So it is intrapolated and it seems to be passing through the origin. Now this kind of a graph, the straight line graph, is a direct proportionality graph. So by this graph, he could easily say that volume is directly proportional to the inverse of pressure, while mass and temperature are being kept constant. Is this clear? So this is how we talk about the variation, the proportionality. Volume is directly proportional to pressure. Now here it would become PV becomes equal to a constant. Again, mass and temperature being kept constant. Is this clear? From there itself, we can have any pressure and volume for the same sample of the gas. We will get P1 V1 is equal to P2 V2, and that's equal to a constant till the time temperature and mass remain constant. The temperature and mass remaining constant would mean the same sample of gas. So that would mean the pressure and mass remaining constant. Is this clear? Now these are the various graphs at different temperatures. This is the graph having the different temperatures. Now as you can very well see that we have pressure, we have the volume, and we have these different values. Many a times the question have been asked, what would be the relation between these temperatures? Fine, understand that. For a temperature, for a higher temperature, V is higher. Clear? So as you can very well see, this is volume. For this particular temperature and this pressure, the volume is the least. Here it is higher, here it is highest. So it is quite obvious that T3 is greater than T2 is greater than T1, because for the same pressure, the volume is higher. Is this clear? And then the Sarkar, isotherm means same temperature. Here it is a constant temperature, and that is why this is an isotherm. Iso means same, therm means temperature. So this is what we have as the isotherm. Is this clear? So we have just got what is the meaning of isotherm. Okay. Now when we talk about the Boyles law are isotherms. So here we have a question, and this question is from NCERT. This is the problem 5.1 from NCERT. A balloon is filled with hydrogen at room temperature. It will burst if pressure exceeds. Actually, it should be external pressure reduces from 0.2 bar. They have put it in the wrong way. Clear? If at 1 bar pressure the gas occupies 2.27 liters volume, up to what volume can the balloon be expanded? Here what we can have is, we are keeping the temperature constant, temperature, mass constant. So if we are keeping temperature and mass constant, then in that case we have the initial pressure. Initial pressure is given as 1 bar. The minimum pressure we can take it to external pressure minimum we can have, or I should say final pressure, is 0.2 bar. Initial volume is 2.24, 2.27. liters. Okay. Final volume, let's say it be V, or you can write it at V final. So what we find is P1 V1 is equal to P2 V2. That would mean 1 into 2.27 is equal to 0.2 into V. So let's solve the question. V turns out to be equal to 2.27 divided by 2, 0.2 is equal to 11.35 liters. I don't think so. There is a lot of confusion in it. There is a lot of calculations in it. Ananya Sarkar, I'll give you the link of the special classes. Then you will be able to find what is the difference in the special classes and the YT classes. Okay, I'll give you the link. First of all, you need to join me on the Unacademy app. I hope you have already joined in the Unacademy app using the code AVLIVE. There you are going to get the link of the special classes. Is this clear? Yes, these are extra classes where we are going to do the questions of the various chapters. We can do anything. We can actually have the sessions. So here what we find is pressure is inversely proportional to 1 by V. Actually it is V proportional to 1 by P. T is a constant, amount of gas is constant. So these are the graphs that we get. Pressure versus volume, it is a curve. Pressure versus 1 by volume is a straight line with a positive slope, and it's directly proportional, while PV remains a constant with V. And you can even have a graph like you can have PV plot with P. That also would turn out to be a straight line. Okay, that also does not change. So these are the graphs. The temperature we have already understood. So this is what we have as the Boyles Law. If you pressurize the balloon, then in that case it gets compressed. You are increasing the pressure, the volume decreases, and the pressure on the balloon keeps on increasing, and ultimately it explodes, it bursts. So that is what we have as the application of Boyles Law. So here is another question. 2.5 liters of a sample of a gas at 27 degrees and 1 bar pressure is compressed to a volume of 500 milliliter, keeping it the temperature constant. The percentage increase in pressure is percentage increase. Yes, Tirthraj, it is free. Special classes are absolutely free. Special classes and YouTube classes are absolutely free. Find it out. Give me the answer. 2.5 liters of a sample of a gas at 27 degrees Celsius and 1 bar pressure is compressed to a volume of 500 milliliter. From 2.5 liter it has been converted to 500 milliliter, keeping the temperature constant. What is the percentage increase in pressure? Are you sure? It's 80% increase in pressure. Ananya, you need to understand that this question is not only of chemistry, it is not only of calculation, it is also of English. This is an English question, and here the fact that you need to know English nicely, that comes into play once again. See, here we have initial volume. .5 liters. That's equal to 2500 milliliter. Clear? Final volume is equal to 500 milliliter. Clear? So initial pressure, one bar. final pressure is not known. Let's say we write it P final. Clear? Keeping the temperature and mass constant, we get 2 2500 multiplied by 1 is equal to 500 multiplied by P final. So P final simply turns out to be 5 bar. It is 5 bar. Now the question is asked is, how much is the increase? What percent is the increase in pressure? What is the percent increase in pressure? So let's find out the increase in pressure. P final minus P initial, and that's equal to 5 minus 1 is equal to 4 bar. Okay. Now percent increase is equal to 4 divided by 1 into 100, that is equal to, the increase in pressure is 400%. Increase is 400. If they had asked by how many times the pressure is increased, the answer would have been 500%. Is it okay? They had asked what is the percentage increase, not by what percent the pressure increase. So that becomes an English question. The increase in pressure is 400%. Clear? Now let's get along with something called the Charles law. When you talk about the Charles law gives the relation between temperature and volume. So it gives us a temperature volume relationship. That is what we have as Charles law. So when we talk about this Charles law, what exactly Charles did? Charles again made a graph. Now in this graph, what he did was he plotted the volume with respect to temperature in degrees Celsius. Well, they could have taken any of the units, but they preferred to take degree Celsius because degree Celsius is easy to understand. We have divided the temperature from 0 to 100, the water's boiling point and the melting point, in 100 divisions. So 100 is easy to calculate. So this is what we have as the temperature. What he did was he plot the volume with respect to temperature, keeping the pressure and the mass the constant. So when he created that graph, he found that the equation, the graph actually went like this. He changed the mass, he changed the pressure, and he got the graphs like this. Now this was V0. Let's say it kept put as V0 dash, V0 double dash, this is V0 triple dash. Now V0 represents the volume of sample at 0 degrees Celsius. What Charles observed was that this graph always seems to be originating. Whatever be the temperature, whatever be the pressure, whatever be the volume, whatever be anything, the graph always seems to be originating from a particular point which was minus 273 degrees Celsius. Ananya, the word is not actual, the word is absolute. What do you mean by actual temperature? Is degree Celsius not the actual temperature? It is absolute temperature. Is this clear? So here, and further what he found was that the slope was always V naught by 273. Please understand that for every graph, if you change the mass or the pressure, the V naught changes. It's not going to remain the same for every sample, but the slope remains the same if V naught divided by 273 is taken. What Charles got the equation was that volume of any sample at a temperature T in degrees Celsius was equal to V naught into 1 plus temperature in degrees Celsius divided by 273. This was the equation that Charles got. Getting it? This is the equation that Charles obtained in this particular case. Clear? So we have the equation Vt is equal to V naught 1 plus T divided by 273. Clear? Now, let's have a simple question, a very simple question. A sample of gas at 0 degrees Celsius has volume 100 milliliter. ठीक है? Calculate its volume at A 136.5 degrees Celsius, B 273 degrees Celsius, C 546 degrees Celsius, D minus 136.5 degrees Celsius, E minus 273 degrees Celsius, and F minus 546 degrees Celsius. You need to give me these 6 values. Quickly give me these values. Ananya, I am going to tell you right now, but first of all give me the answer to this particular question. Give me the answer to this question. There are 6 answers that you need to give me. 136.5 degrees Celsius, 273 degrees Celsius, 546 degrees Celsius, minus 136.5 degrees Celsius, minus 273 degrees Celsius, and minus 546 degrees Celsius. Could you give me this answer? What will be the volume at these particular temperatures? The formula is written right in front of you on the board. You just need to put the values in this formula and you are going to get the answer. Mayuk Sen Gupta has given the first answer. The first answer is 150 milliliter. Okay, perfectly right. So this is 150 milliliter. Okay, what's the answer? Second one answer. Great, Mayuk has given the second answer also, third answer also, and fourth also. Wow, this is 200 milliliter. This one is 300 milliliter. This one is 50 milliliter. What about the other two? This one comes out to be 0 milliliter, and the problem with this is this one turns out to be minus 100 milliliter. Everybody got these values, or they didn't get the values? Mayuk has given the answer. What about the others? Ananya, you have not given me the answer. Everybody agrees with these answers, and those who have not liked the session, just go ahead and like the session. Now, there isn't any problem with this. This one is fine, this one is fine, this one is also fine, this one also is fine, but there is a slight problem here. How can the volume actually become zero? A zero volume would say that the gas simply doesn't exist. It is absolutely ceased to exist. Gas does have a mass, and if gas has a mass, it is also true that it's going to occupy some volume. But fine, zero is still acceptable, What about negative volume? What is the meaning of negative volume? A substance ceases to exist is acceptable, but a substance becomes negative existence, that's not acceptable. So it comes from these calculations that the volume cannot go below zero. If the volume cannot go below zero, it would imply that the temperature cannot go below minus 273 degrees Celsius. So minus 273 degrees Celsius becomes absolute zero. That is, a negative to that is not possible. So whenever we talk about absolute, absolute means that this is the final thing. Below that or above that, the value is not possible. So this minus 273, actually it is 0.15 degrees Celsius, becomes absolute zero of temperature. Now this absolute zero of temperature in respect of Lord Kelvin was termed as 0 Kelvin or zero absolute. So 0 Kelvin becomes the lowest possible or impossible temperature. A temperature below 0 Kelvin is not possible. Is this clear? This formula, this is in degree Celsius. This also is in degree Celsius. Is it clear? So Ananya, is your answer question answered? What is absolute zero? Mayuk, can we create absolute temperature, zero temperature accurate practically? Beta, I cannot create it. You need to search on the net if anybody has been able to create it. Actually, temperature is the measure of average kinetic energy of the particles. Once the kinetic energy has become zero, how would you take out further energy from the system to make the kinetic energy negative? Will you be able to make the kinetic energy negative? And that is the problem. And will you be able to make the particles absolutely still? We have been able to reach, or the scientists have been able to reach within fractions of 0 Kelvin, but I don't think so they have been able to achieve 0 Kelvin on Earth. Maybe in universe someplace where there is absolutely no energy available, no absolute thermal energy available, there might be the temperature going up to 0 Kelvin. Is this clear? Well, I perfectly know that I used to argue with my physics teacher. We had a chapter called Universe, and in that universe chapter we were talking about the birth of a star, and there we talked about that the temperature of the gas clouds is minus 40 degrees Celsius or minus 140 degrees Celsius. I was considering myself to be very intelligent, and I asked my teacher why the temperature of those gas clouds was not 0 Kelvin or minus 273 degrees Celsius. I had a little bit idea about absolute zero. I was so ignorant of one particular fact that these gas particles, since they are going to attract each other due to the force of gravity, they would still be having some motion. And since they have some motion, the temperature is not going to be absolute zero. Absolute zero would mean absolute still system. Is it clear? Okay. So that is how we talk about the Charles law. Clear? So that is the equation, the Charles law equation. Clear? But then if we are talking about absolute temperature, then in that case the graph becomes a straight line passing through the origin. Clear? So here we get the relationship, and that relationship turns out to be V is directly proportional to temperature in Kelvin, the absolute temperature. Is this clear, Ananya? That's what you were talking about. Clear? You were saying that the Charles law says that the pressure remaining constant, the volume of a fixed mass of a gas is directly proportional to its absolute temperature or temperature in Kelvin. Is this clear? There are very few people watching, only 9 students here, and do we have all the likes required? So this is what we have as the temperature relation with volume. So that would mean V upon T is a constant at constant pressure and constant mass. That is, the sample of the gas remains the same. We do not change the sample of the gas. So that is what we have as the Charles law. Clear? So here is the graph that we have. You need to understand that lower is the pressure, higher is the volume. So for this particular pressure P1, we have the highest volume at a given temperature. So P1 is the least pressure and P4 is the highest pressure. Least volume. Here it is most volume. Is this clear? Sarthak, what is your doubt? You can simply ask the doubt right here rather than telling me that I have a doubt. Just ask the doubt. Now here we are keeping the pressure constant. So keeping the pressure constant, it is known as isobar. Clear, Mayuk, Tirthraj, Ananya? This is what we have as isobar. Iso again means same, bar means pressure. So these are the graphs which are drawn keeping the pressure constant. So that is why they are termed as isobars. Can you provide formula sheet for this chapter? There is only one formula. We have not reached up to that formula as yet. So we are going to talk about that formula, and I am going to provide you the formula sheet also. You can just simply copy down that formula. That's only one formula. We have not reached it. We have not reached the ideal gas law. Okay, so that's what we have as the Charles law. Is this clear? Any confusions? So here's a question. On a ship sailing in the Pacific Ocean where the temperature is 23.4 degrees Celsius, a balloon is filled with 2 liters of air. So here T1 is equal to 23.4 degrees Celsius, which simply means 273.15 plus 23.4 Kelvin. Please understand that from today onwards, from this instant onwards, you are going to use the temperature only in Kelvin. You are not going to use the temperature in degrees Celsius in any of the calculations. Whenever you are going to ask or you are going to do the calculation, you will convert the degrees Celsius into Kelvin, and that is not a very difficult task, because to convert degrees Celsius into Kelvin, you just have to add 273.15. In most cases, 273 works fine enough. 0.15 is also not required. Yes, Ananya, this is our chapter question page 143. Clear? That is T1, and V1 is equal to 2 liters. What will be the volume of the balloon when the ship reaches the Indian Ocean, where the temperature is 26.1, and here we are considering that the pressure remains constant, and that is how it becomes the question of Charles' law. Is this clear? Any student who have not liked as yet? So here it's going to be the question of Charles' law. So T2 is equal to 26.1 plus 273. And V2 we need to find. So use the formula, use the calculation, and get the answer. Any kind of doubts? So this is what we have as the Charles' law. V is proportional to temperature, absolute temperature. The graph is a straight line passing through the origin, that is minus 273.15 degrees Celsius, and here we have the pressure relation. Now, application of the Charles' law are numerous. Here we are talking about the cakes and the fluffy things. That is because the air trapped in them expands on heating, and that makes it fluffy. Clear? Akash Patwat, beta, we have very less student in all the sessions. What's new thing about it? Clear? So this is what we have as bread and delicious cakes, also our gifts of Charles' law, and now we get along with the Gay-Lussac's law. There are two laws of Gay-Lussac's. There is the law of Gay-Lussac's law of combining volume, which is there in the first chapter, that is laws of chemical combination, but there is a Gay-Lussac's law of gaseous state also. The Gay-Lussac's law talks about the relation between pressure and temperature. Now, this law simply tells us that as we increase the temperature, the pressure increases. So, Gay-Lussac's law actually talks about the pressure being directly proportional to temperature. As the temperature increases, keeping the volume and the mass constant, the pressure keeps on increasing. And this is responsible for bursting of the substances when the temperature is increased while keeping them sealed. Akash Patwa, the basic concept has law of chemical combination, Gay-Lussac's law of combining volumes. This is Gay-Lussac's law of gaseous state. Those are the two different laws. Clear? So here it turns out to be pressure is directly proportional to temperature, and as the temperature decreases, the pressure keeps on decreasing. At absolute zero, the pressure should also become zero. Any kind of confusions here? So that's what we have as Gay-Lussac's law. Again, we are having the pressure and temperature and the volume. For as the pressure increases, the volume should decrease. Higher the pressure, the lower would be the volume. So what about V1, V2, V3, V4? V1 should be less than V2, should be less than V3, should be less than V4, because more is the pressure, less would be the volume. Is this clear? They are inversely related to each other. And when we talk about this pressure cooker, the pressure cooker increases the pressure inside, and that's because as the temperature increases, the pressure inside increases. Clear? But please remember, the pressure cooker does not cook with increase in pressure. The pressure cooker cooks due to the increase in the boiling point of water. The temperature increases and it is cooked due to the increase in temperature, not due to the increase in pressure. Is this clear? Ten gram of a gas at atmospheric pressure is cooled from 273 degrees Celsius to 0 degrees Celsius, keeping the volume constant. What would be its pressure? The pressure was atmospheric pressure. So could you give me the answer? It becomes 1/4 of atmosphere, it remains the same. It becomes half atmosphere, it becomes twice of atmosphere. What would be the answer? Is it a difficult question? Give me the answer quickly. Understand that 273 degrees Celsius is equal to 546 Kelvin. 0 degrees Celsius is 273 Kelvin. So you have actually made absolute temperature half. The pressure is directly proportional to temperature, so that if the absolute temperature becomes half, then the pressure should also become half. Ananya, why don't you make the notes while seeing the class? Why don't you note it down? I can send you the notes, that's not a problem, but that would be more like giving you crutches, where you would like to see the notes. All the notes are on the screen. Why don't you make them? It won't remain same, Ananya. It is actually going to decrease, it's going to become half. Clear? And then comes Avogadro's law. When you talk about Avogadro's law, till now we are keeping the mass constant. We have changed the volume, we have changed the pressure, we have changed the temperature, but we are keeping the mass constant. Now Avogadro's law talks about the amount of the gas. Amount would mean the moles, the number of particles. What Avogadro said was that each gas particle, irrespective of its own properties, is assigned a fixed volume. It is something like whether your height is 6 feet or whether your height is 3 feet, you are assigned the same space in a train coach, or in an aircraft, you are assigned the same seat. So irrespective of your own size, you are given the same size, and irrespective of the size of the people traveling in the train, the number of people traveling in a train remains a constant. In the same manner, whatever be the actual size, mass, or the property of a gas molecule, it is assigned a specific volume which is absolutely independent of the nature of the gas. But this volume actually depends on two factors, temperature and pressure. Clear? So here comes the Avogadro's law, which says the equal volume of all gases under the same condition of temperature and pressure, will contain the same number of molecules, since the number of molecules is dependent on temperature and pressure, because each molecule is assigned a specific volume depending on temperature and pressure. Is that clear? Yes, Ananya, we are going to talk about the Avogadro's constant also. Clear? So that is what we find, that volume is directly proportional to the number of particles. Since each particle has a specific volume, as the number of particles are going to increase, the volume also increases till the time temperature and pressure are remaining a constant. Is this clear? So that is what we have as the Avogadro's law. So as we are pumping the gas into a particular balloon, we are increasing the number of moles and the balloon is going to expand. Is this clear? 4 1-liter flasks are separately filled with gases O2, F2, CH4 and CO2 under the same conditions of temperature and pressure. The ratio of number of molecules in these gases is 1 liter gases, same conditions. So, what's the ratio? Do you need to calculate it? I don't think so. No, you don't need to calculate it. The answer is so. Here we end the session. The iconic mega sale week is going on. You can prepare today for your prosperous tomorrow. You can go ahead and join with us. Now, please remember this particular session, this particular scheme is, I believe, only for today. Okay. So, today it's going to end. So, if you wish to join, go ahead, use the code AV Live and join with us. Okay. The code is AVLIVE, AV Live. Next class is tomorrow. We have the next class tomorrow, and tomorrow is a marathon session of surface chemistry. So tomorrow we have surface chemistry marathon. We are going to start and finish surface chemistry tomorrow itself. So be with me tomorrow at 12 p.m. Every day, Monday to Saturday, 3 p.m. is biology class with Dr. Sachin Kapur. 4 p.m. is chemistry class with me. And very soon we are going to start with botany and physics class as well. Okay. You can join our Unacademy app, download it from the Google Play Store, install it and put in your goal. Go ahead and take it up. So this is what we have as various subscription. This is my page on Unacademy. Go ahead, join this particular page, follow it and see all the previous classes. You will be able to have an idea about the special classes also here and the plus classes. Plus classes you won't be able to access at this moment if you have not taken the course. If you have taken it, you will be able to access the plus classes as well. Is that clear? So join with us, Unacademy NEET Elixir, for the best live classes. Like, subscribe, share and also comment on this session so that I'll be able to understand what exactly you were able to understand and what not. I hope my English is fine enough. You are able to understand this particular English. Thank you. We'll meet tomorrow at 12 p.m. with the marathon session of the surface chemistry. Clear? All the best.